Hello everyone. It's already 6 p.m. and I think we should begin with the session. And there are currently only six attendees for this live session. I don't think so. There will be more. And anyways, if they can join it later also if they wish to. So, see, there are more people coming now also. So let me first introduce myself. I will turn on my camera. So, hello, I am Sanjay Kumawat. I don't know whether you got my introduction through live session 0 or not. I'm not pretty sure whether the live session was shared, live session 0 was shared with you guys or not. But in case if it was not shared, I would be like introducing you. I am Sanjay Kumawat. Okay, so there are multiple joinees coming. Let's wait for them also. People are still joining. Now we have 14 number of attendees. Okay, I think we should begin now. Let me introduce myself. I am Sanjay Kumawat, a PhD student from IIT Bombay, and I would be taking all the live session for this course, Reinforced Concrete Structure, these NPTEL live sessions of this course. This is the very first live sessions, and I know you all have not much uh, got into this subject or not much read or not much learnt about many things which are involved in this subject. So in this very first session, I don't think I would be able to take many or much of the numerical problems, or I would be able to solve many numerical problems with you guys. But I'm pretty sure that I will be taking one a good numerical problem which will be like you will be able to solve it, and you will be that problem will be able to clear many of your concepts, and it will be like very useful for your future learning in this subject. So let me first share my screen with you. Can you see my screen? Can I get a reply from you guys in the chat box?
Yes, sir.
Okay, thank you for the reply. So, as I already introduced myself, today is the first live session, and for the today's session, I will be taking only a small one numerical problem, which will help you to clear a little bit of your concepts regarding the reinforced concrete structures. So, in the first week, we had a total of three lectures, and I'm assuming you all must have gone through them. So, what all we have learned from those three lectures is the what are the various material properties that we would be dealing with in this subject, and what all are the different methodologies with which we are carrying out the design of our structures. So, you must be pretty much aware of this all properties, I think so, by now. So to begin with, now I will share. Okay, so this is the a very so there are still many attendees joining, so I am getting disturbed in between. Okay. Okay, so this is a typical reinforced concrete frame. So as you are already aware by now that a reinforced concrete building, what it would be having, what all are the various components that we have in this reinforced concrete structure. So what all are these various components we have? The first one we have is a slab, and the slab after that we have a beam which is numbered in 2, and then what we have is a column which is numbered as 3, and then we have the foundation. So you know how the load transferred in a reinforced concrete building works. So in a reinforced concrete building, how the load transfers work? Firstly, the slab load. So what all load a slab can have? Can you all just reply me in the chat box? What all types of load a slab can have? I I think this should be an interactive session, and you all must be very active in these sessions. So I'm expecting a few replies from you guys. Can you all just reply me what all type of loads on a slab we can have? You can reply me in the chat box. Okay. So some students are saying dead load, live load. Okay. So what all type of dead load do we have in slab? Can you just name one or two types of dead load that we can have in the slab? I hope my question is very clear. Okay, so people are replying beam, self weight. Okay, very good. What else? Floor finishing. Okay. What else? Okay, fine. So basically, we have two types of load: dead load and live load. So dead load can be of either the load of the partition walls, either the load of the finishing work, that is the load of the tiles, or the finishing load, or the self weight of the beam, or the self weight of the slab itself. So these are all the dead load which are acting on the slab. So this dead load, it is getting transferred into the beams. So this is the beam which is numbered as 2. Then what this beam will do, this beam will transfer the load to the column. Okay, then the column will transfer the load of the entire superstructure into the foundation, and the foundation will transfer it to the soil, and the soil will be having some bearing capacity. That bearing capacity we will be getting it from geotechnical engineers, and based upon that the foundation will be designed. So why I am showing you this diagram, the purpose of showing you this diagram is to clear your very basic concept in RCC. That is the slab. What is the first component of a reinforced concrete building that we are supposed to design? The very first component that we need to design is the slab. After the slab, what we will be designing, we will be designing the beam. After beam we will be designing column, and after column we will be designing the foundation. I think this is very clear for you now by now. So coming to the slab, you all have already answered me that the slab can have two types of loads, that is dead load and live load. And inside that dead load and live load we can have further classification that we will be seeing in the further slides also. So now let's focus on the slab only. Can you guys answer me in what manner a slab can be designed, for what type of forces or what type of stress resultants the slab is designed? Can any one of you answer me? What type of forces can a, or what type of forces are predominant in slab? Can I get some answers? Okay, so I think
Now,
you.
like
Okay, okay. Who was speaking?
Vinota is
Sorry, I didn't hear you.
Vinota is
Okay, so what are you saying? I have just asked a question. Are you replying to that question, or you are just replying your name only?
yes, sir. I will give the answer
Okay,
now.
okay.
The answer is live load, dead load.
Okay, that's fine. That's fine. So you are saying dead load and live load are acting on it, but okay, I think you all are not very familiar. So it is now my job to make you familiar with this. Okay, so thank you for your reply, Vinoda. Yes. So I think by now you have studied the courses solid mechanics and engineering mechanics. So I think you should be familiar with this type of words like stress resultant. Okay, someone was speaking. Okay. So what was I saying? You all must be familiar with some technical words such as stress resultant. So the slab they are basically designed as a beam only. During the design of slab, what we do, we assume it of a width of 1,000, and for that 1,000 for that 1,000 what we are designing the slab for bending. So a slab can be of two type. It can be either of one way or two way. So based upon that, the reinforcement in the slab is provided. So I know this is a very early stage for you guys, but with time you will be getting more clear with these concepts. Just bear with me. This is the slab. So slab can be of two types, one way or two way. So why I am classifying this slab as one way or two way? So keeping aside the technical terminologies, I will be explaining you the types of slab in a very layman language. So a slab can be of two type, that is of one way or two way. So one way slab means it will be getting deflected only in one direction. Okay, so in order to deflect the slab in only one direction, it should have only a large dimension in one direction only. So for example, one of its side is very long as compared to the other side, so that slab will be of one way type because it will be getting deflected only in one side. Now coming towards the two-way slab means both of the dimensions of the slab are equal, or they are comparative, or what we can say, the technical, in technical terms we say that both of the ratio of both of the sides of this slab is less than 2, so we call it as two-way slab. Okay, so two-way slab, what can we say? The two-way slab, we call it two-way because it can deflect in two directions. So that's the reason we call it two-way slab. So based upon the directions or the ways in which the slab can deflect, we are classifying it and then we are designing it. So two-way slab will be having main reinforcement in two directions, while one-way slab will have main reinforcement only in one direction. So let it be. You will be like getting more familiar as the course, as we proceed more into this course. So that's I was just about, I just said this because I want to make you familiar that slab, it is also designed for bending moments only. Then coming towards beam, I think you all must be familiar. Beam is like the predominant forces in beams are shear force and bending moment. So we design it for shear force and bending moment. We provide reinforcement in beam for both bending moment and for shear. Then coming towards the column, for what all type of forces do we design the column? Can you all answer me? You can also see the type of force acting on this column. Can you answer me what type of force for which the column is designed? Okay, so Piyush is answering we are designing it for axial force, so that is very correct. So that's right, we are designing the column for axial force, but at the same time, in some cases we also need to design it for moments. So we can design the columns for axial force or for a uniaxial moment, or we can design it for a axial force or for biaxial moment. So why this moment is coming into this column? Because all of the columns are not purely acting upon by an axial force, it is having some moment because of this beam load. You can see it here. So we need to design the column for both axial as well as uniaxial or biaxial moment. And coming toward the foundation, once we find the load from the column into the foundation, we design the foundation for the forces which would be acting on it. So here also you can see we can design it as a cantilever beam. So here also we have different types of bending moments and different design criteria for designing the foundation. So I think you all are now pretty much very sure what type of loads or what type of stress resultants we are using for designing different components of a reinforced concrete structure. So just keep this in your mind that for beams, the predominant forces are bending moment and shear force. So mainly the bending moment in beams we are designing the reinforcement for, and in slabs also we are designing it for bending moment only. So now moving on to our main problem, let's look at the main problem. I have bought a very good problem for you guys. Okay, so this is our problem. I hope you all can see it. So don't get scared with this problem. It is a very easy problem, and you all can solve it by your basic knowledge from engineering mechanics. That is, you only need to convert some line loads into a point load or some triangular load into some point load. So I already said you there are two types of slab, but you are not very familiar with types of slabs and what type of load distribution we use for different types of slab. So I have already given you the load distribution from the slab. So I have explained you in very detailed manner that how load from a slab it get transferred into the beams, and from beams it get transferred into the columns. So these problems deal with my that explanation only. So since this is a very first class, I am not using many design terminologies, and I am not using many codal provisions, because at this stage you will all get confused with all those. So I am just solving this problem from a basic mechanics point of view. So now let me read this question for you. The slab of the figure which is shown has a thickness of 150 mm, and in addition to its, okay, it has a thickness of 150 mm, and in addition to its own weight, it supports a 0.85 kilonewton per meter square of partition, and a live load of 2.4 kilonewton is also acting upon it. Transfer the load of the slab to the beam on all four sides in the form of line load. Unit weight of concrete is it is given, and they are saying us to assume ultimate distributed load on slab in this manner. Then they are asking us to calculate the maximum bending moment on the beam and the axial loads on the columns. So I think this is a very simple problem. I will explain you. After that, you will be also able to see it like a simple problem. So what they are basically saying us to do is, they are saying like we have a frame like this. We have a frame like this. Now different types of dead load and live load are given on this frame. They are asking us to transfer this load onto the beam, and then they are asking us to calculate the maximum bending moment on the beam, and they are asking us to find the axial force onto this column. So see how many concepts we are getting clearing from this problem. Now we know that firstly we need to transfer the load from the slab to the beam, then from beam to the column, and then finally to the foundation. So now I want you all to think of how the different types of loads are acting on this slab. I have already given you the load distribution. See, let me explain you how this load distribution are acting. Firstly, this is the slab. This is a rectangular slab of 6 by 4 meter, and these are all the beam at the periphery. This is a 6 meter beam, this is a 6 meter beam, this is a 4 meter beam, and this is a 4 meter beam. So we have four beams. So we need to calculate the maximum bending moment on these four beams based upon the load which is acting on this slab. So I think by now you are getting familiar what we are trying to solve in this problem. So what we are also given some aerial loads. So these loads are with a meter, with a unit of kilonewton per meter square. So kilonewton is the unit of force, and they are distributed into the area of this slab. So what all types of load we have? We have a dead load of 0.85 kilonewton per meter square. We have a live load of 2.4 kilonewton per meter square. Can any one of you tell me what, apart from these two load 0.85 and 2.4, what is the other load which is acting on this slab by reading this question? The question says the slab is of thickness 150 mm, and in addition to its own weight, we have this extra dead load due to partition. Okay, what is partition? What do you mean by partition? Why this partition load is coming onto this slab? Separation, okay. What this separation is made of? Separation means what? Okay, I'm getting you what you are trying to say. You are trying to say, okay, Vipul is saying brick wall. Okay, Sharon is also saying brick wall. That is very good. So partitions, we have a partition wall in between two rooms, or what we have is we have different types of, not even brick now. Nowadays we have different types of partition blocks, AAC blocks like aerated cement concrete, or we have fly ash bricks. We have different types of material. So we have this dead load due to this partition, and the live load is coming because of some people living into this building or into this structure. So apart from this two load, can anyone of you, or can anyone of you think of some other dead load which is acting on this frame or on this slab?
Sir, excuse me, sir.
Yes,
Sir, where is the location of partition involved, sir?
actually the partition wall, they are basically located upon these slabs, like upon this beam. Okay, this is a very good question from uh, Thiruganam. Okay, I am not able to pronounce your name, but this is a very good question. He is saying, where is this partition load acting? Actually, this partition load, they are basically acting upon these beams. We basically make partition, uh, we make basically makes the brick wall upon these beams. But now in this question, they are not giving us the partition load in the form of a line load. They are giving us it in the form of aerial load. So they are, what they are actually trying us to say, they are saying us that this partition load, it is distributed uniformly upon this slab. Did you get me? The nature of this question is, they are saying now the partition load, they are not giving us it in the form of a line load which is acting upon the beam. I know what you are thinking. A brick, it should be like a vertical wall. It should be like an UDL which should be acting upon a particular line, basically upon the beam. But now in this question, what they are saying, the partition load, which is the load from the brick walls, they are coming, they are uniformly distributed over the entire slab, and the value of that partition load is 0.85 kilonewton per meter square, and the dead load is this. Now what was I asking is, what is the other kind of dead load? Please answer me fast. Self weight. Okay, okay, very good. Self weight. And Atif has also answered the self weight, uh, pointing out at the thickness. Very good. So, what all dead load we have now is the dead load due to the dead load due to the slab, self weight of the slab. We have a dead load due to partition. We have a live load. Okay, very good. Now, what we they have also given us the unit weight of concrete so that we can calculate the self weight. Okay, fine. Now, what they are saying us that assume an ultimate distributed load on the slab of this type. So they are basically, they, I know you are not very familiar with the various types of factor of safety. So that is the reason I am giving you this relation for the ultimate distributed load. So they are saying us like multiply the dead load by 1.2 and multiply the live load for 1.6 and add both of them to get the ultimate distributed load on the slab. So this is just basically a factor of safety. What in case if we have an increased dead load or we have an increased live load? So to consider all the different types of miscellaneous activities onto our building, we are taking up the factor of safety. So they are asking us to take this ultimate load on the slab. So firstly, what we need to do, we need to find the ultimate aerial load which is acting on the slab. So let's look how it is done. Okay. So firstly, we need to calculate the total dead load. We have only the total load 0.85 of partition, but what about the self weight? The self weight of the slab, it is calculated as the slab thickness into the concrete unit weight. Can anyone of you tell me why we have done this? How we have calculated the self weight? Why we are multiplying with the thickness and not with the lateral dimensions? Yeah, it's fine. I know it's dead load. But why we are not multiplying it by 6 or 4? Why we are multiplying it with the thickness?
Per meter square area, sir.
Yeah, very good. So per meter square area, we are, because the dead load and live load, they are given for this entire area, not for the thickness. So we are just eliminating the 1 meter from this unit area. So now the self weight of the slab also we have it now. So we have the total dead load now. We can calculate the ultimate distributed load on the slab. Okay, so total dead weight, it has been calculated, and now we have the ultimate distributed load in this form, and I have already calculated it for you. You guys will be getting this notes as well as the recorded video on YouTube. So, but I personally suggest you to also solve it parallelly with me, because that would be more time saving for you, and you will be learning more of your concepts will be cleared if you solve it during the live session only. So that is my personal suggestion, and the rest of you, it depends on you only. So this is the ultimate load we have, 8.7. So this is the final load for which we are going to uh, design this slab. Okay, we got the final load for which we are going to design the slab. Now we have what it is asked in this question: transfer the load of the slab to the beam. So I have already given you the type of distribution. You can see this is the triangular distribution for this beam. This is the trapezoidal distribution for this longitudinal beam, and this is the shorter beam. So can any one of you tell me how to calculate the total load acting on this beam, or how to transfer this load onto this beam? Can any one of you answer me? Believe me, this is going to clear a lot of your concepts. Yes,
Sir, isn't the triangular loads formula is 1 by 3 WU into L?
1 by 2 WU into L.
1 by 3.
1 by 3. Okay, very good. Okay, so who was this? Shivam. Okay, so Shivam, you gave a very correct answer. But before going to this formula, actually, that was our final answer that I was going to derive and explain you. But this is very good. You already know this. Can you explain me how did you come up to this expression? Why didn't you directly multiply this 8.7 into this area, triangular area, and got the total load?
Sir, actually, I had checked in the book.
Yeah.
It was given that it was at the center of the triangle. There is there is load is 1 by 3 WU into L. It's I think it's the centroid, something related to centroid.
Okay, you have checked it into the book, so your answer is very correct. But the explanation you give for it, I don't think it is very much correct because there is nothing related to the centroid of this triangle. Actually, I will be explaining you why we are using WL by 3. For the time being, let us all forget we have something called WL by 3. As a layman or as a person who have only knowledge from engineering mechanics, what we can think how to calculate the load acting on this beam. We have a total load of 8.7. The area of this is 8.7 kilonewton per meter square. Now I want to find the load on this beam. What you will do, normally what we can do, anyone calculate area of triangle and multiply by 8.7. Okay, very good, Hardik. So we already have the area of triangle. We have ready-made area of triangle as 4 meter square. So what we will be doing, as Hardik and Sharon and Vinod, yes, has suggested, we can directly multiply the area of triangle. And actually this is basic knowledge we have. We can look at this problem and we can think in this manner, like we should multiply the area with this load to get the total load. Yeah, that is a very common sense. So we have done that. We will be transferring the load from the slab to the beam in two cases. In the first case, we will be doing it in this way. Okay. And in the second case, I will be like making you realize what is the reality of this problem. So let first focus on the case one of this problem. So the case one of this problem says we need to directly multiply the area of triangle with the total load. Okay. It is very simple. So we got the load on this beam as 34.8 kilonewton. But what they are saying in the question, transfer the load of the slab to the beams on all four sides in the form of line load. So this is not a line load, this is a point load. How to convert this into a line load for this beam? Anyone? Anyone? How to convert this point load divided by the length of the beam? Very good, Hardik. So we can divide this by the length of the beam and it will be get converted to UDL. As simple as that. Okay, so this is the load we line load which we got this for this beam and for this beam. So it is a symmetrical type of slab. So for both the beam, shorter beams, we have this line load. Now you can also easily calculate the uniformly distributed load for the longer beams. How we will be calculating it? Can you answer me? So you have on the next page, you have this trapezoidal area has 8. 8 multiplied by what? 8 multiplied by 8 is the area. Okay. So let's see what's the answer. 8 multiplied by what you are doing? I'm not getting 8.7. 8.7 is the answer for the triangular load. Okay. That's fine. That's fine. Now just answer me for the upper beam. This is a trapezoidal type of aerial load and we need to get the point load on this longer beam. What is the answer? On this longer beam, 8 multiplied by 6. 69.6. How did you get it? Okay. Okay, very good. Okay, fine. Okay, please, some of you are getting some different answer, 52.2. I don't know. How did you get that? So this is the two answers which we have. Okay, I think the okay, you are saying 11.6 is the UDL. Okay, fine, people, fine. I get you. So now we have the line load for both of these beams. So now we are proceeding to the design of beams also. We have already calculated the area load on slab. We can design the slab now. How to design the slab, that we will be looking into the further sessions of this course. But for the timing, let's first see how we transfer the load from the slab to the beam. So we have transferred the UDL onto the beam. Now I think it is very easy to calculate the maximum bending moment from this uniformly distributed load. We have 11.6 kilonewton per meter uniformly distributed load on this beam, and here also we have a uniform. Just assume this as a simply supported beams, and you all can calculate the maximum bending moment. Can you all do it? Just reply me with yes in the chat box if you can do, or you can calculate the maximum bending moment with UDL onto these two beams. WL square by 8. Yes, very good. So you can do that. So now we have a W of 11.6 onto this beams and 8.7 onto this beam. Okay, that's fine. Now, now I will be showing you a case 2 of this problem, which I think some of the one of the student has already pointed out that he has read it in some book. But why is it so? I will be explaining you. Now, as a normal person having a knowledge of engineering mechanics, I was able to think by this method. There is no harm in using this method. If you are using this method, calculating the load by using this method, and you are designing my reinforced concrete structure by using this method, your structure will go nowhere and it will be safe only. But your structure will be very uneconomical. Okay, sorry, not uneconomical, but it will not be. I should have said it would not be an conservative design, or I think it would be an unsafe structure in future. So why I am saying this? Let's look at the case 2. Now I am saying you that the triangular load distribution, it will be coming by the formula WLX by 3. Why is this? I will be like explaining you in the further slide why I am saying you that the triangular load distribution is not area multiplied by this, but it is something which is calculated by this formula, triangular load distribution. So we have an answer of 11.6 kilonewton for 0.6 kilonewton per meter, as compared to what in the previous slide we had an answer of 8.7. So this is less as compared to this 11.6. So 11.6 is more conservative design. Why we are using this formula, I will be explaining you. First, let's also look at the other one. For the longer beam, we have a formula, some a tedious formula like this, which I think you can remember or you can not remember, but you can definitely derive it after I make you understand, where K stands for Ly by Lx. And when I substitute the value and calculate the line load onto this longer beam, I am getting a value of 14.88. So this is also higher as compared to 11.6. So sorry, I said you previously that your building will go nowhere if you go by this design, but I think the building will go somewhere, or that will be a not very conservative design. So what do I mean by conservative is you are not taking the maximum load for the design of the structure. So now now the question is why I am using these differently looking formulas.
We want to average out the load on the beam.
Okay, you want the average of the load on the beam. Okay, that's a fine answer. You are going away close to the actual answer. Can some anyone else can think of a better answer? Can anyone of you think of a better answer? Hello, am I audible? Hello, hello, hello. Sorry, there was a network crash from my side. Am I audible now?
Yes, sir.
Yes.
Oh, sorry, sorry for
Yes.
that. Extremely sorry. Let me again share my window. Can you all see?
Yes, sir.
Okay, okay. Extremely sorry for that connection lost. I think that is the reason why people are keep joining in between. Are you all also facing with the same issue which I just went through? Okay, that's fine. So what was I saying? Now we have some different formulas which we are not familiar with. Some guy told me that WLX by 3 it must be related with some centroid of the triangle. But how would you explain this then? What is this? And I also got one answer like we are interested in calculating the average load on the beam. Okay, you are like you all are thinking in a good manner. Just keep thinking and explore new things. But the actual reason behind doing this is something else. Uh, just before some time, I told you that there are certain types of stress resultants for which we are designing different components of building. Okay, so I told you that a beam it is having some kind of stress. So can you all just remind me for what type of stress resultants we are designing the beam for? What are the predominant forces in beam? What all are the predominant forces in beam? Bending and shear. Okay, very good. So what I said, what did I said you just a moment back? I said that we are interested in calculating the maximum bending moment onto the beam. So the manner which we are calculating the maximum bending moment onto the beam, it is not correct. What we are doing, we are converting this triangular area load into a UDL line load, and we are converting this trapezoidal area load into a UDL line load just by directly multiplying it by the area and then dividing it by the length. So this is a wrong way, and by this way we cannot get the maximum bending moment which would be acting due to this triangular or trapezoidal area load. So the correct method or the correct terminology to find the maximum bending moment onto this beam is, what we can do, what we are interested in is we are trying to equate the, just a second. Okay, so what we are doing, we are just trying to equate the bending moments of this aerial triangular load to what, to with this UDL load. What we are doing, we are converting a triangular load into a UDL, or we are converting a trapezoidal load into a UDL. Hello, am I audible?
Yes,
Yes,
sir.
sir. Yes, sir.
Okay, so what we are doing, we are trying to convert this to we are trying to convert this triangular load. So first, let's take this first case in which we are converting this triangular aerial load into this UDL load. Okay, so so what we will be doing, we are interested in finding the maximum bending moment for the beam at the center. So at the center, what we will be doing, we will be equating the maximum moment, bending moment at the center of this beam to the maximum bending moment at the center of this beam. Okay. So what we will be doing, we will be equating the bending moment of these aerial loads. Just remember these are aerial loads because slab it always gives aerial load, not line load. So this is W0 per meter square. This is W per meter square. We are converting this triangular aerial load into a UDL aerial load. Okay, UDL or rectangular aerial load, whatever you can say. So, can anyone of you just tell me what will be the maximum bending moment here? What will be the maximum bending moment? I think it will take some time. Can you just tell me what is the maximum moment for this UDL case, normal UDL case? Normal UDL case, that is easy. For a simply supported UDL. Actually, this should be a roller, wrong diagrammatic representation. Hello? Hello? Can you tell me the maximum bending moment?
So WL square by 12.
Okay, that's not correct. WL square by 8 or 12. Sharon is saying 8. Vipul is also saying 8. Okay. So we know the maximum bending moment for this. We also know the maximum bending. You can calculate it very easily. So let me display the answer for you. So the maximum bending moment for this case is this, and for this case. So what we are interested in finding this W. You are getting me? We are interested in finding because we are converting this triangular aerial load into a rectangular aerial load. So we want this W, uniformly distributed load on the beam. So we can get this W just by cross multiplying. We get this W as 2 by 3 W0 per unit square. This is in unit square. So now what can I conclude? Now I have converted this triangular load into a UDL load. Okay. I have converted this triangular load into a UDL load. So now this UDL load or this rectangular load, it can be converted from kilonewton per meter square to kilonewton per meter just by simply multiplying it by L by 2. So I have done that for you. So finally what we get after multiplying that per unit square with L by 2, I get this W0 L by 3. So that's what we have used in the previous slide if you remember. For triangular we are using this WLX by 3. So this is the way we are getting this triangular distribution on this beam. So see, this is very important in designing. So in designs we have to like look at the various maximum forces that we can get by converting the different aerial loads to the line load. We cannot just directly multiply it by the area and like a normal person I will be just calculating it. We should first focus on what will be the what in what all manner we can get the maximum force onto these beams, and then for that maximum force we need to design it. So we have seen that when we calculated the max we have when we have equated the maximum bending moments of two aerial loads from a triangular to a UDL, we are getting WLX by 3. And for trapezoidal also we can get this. We can just simply do the procedure. We can calculate the maximum bending moment for this type of load and equate it again with WL square by 8. Okay, so this was what I am trying to convey you. So like this has, I think this should have cleared some of your concepts. We cannot directly calculate the load like we do in engineering mechanics. So now we have to follow some codal provisions in reinforced concrete structure subject, and with the help of these codal provisions we will be able to design our structure in a very beneficial and economical manner. So now I want you guys to find or to derive the formula. The formula I have already given you for the trapezoidal load of that, uh, the trapezoidal load converted to UDL. I have already given you that formula in the slide number 2. Now I want you guys to revise the similar step and derive that. So you can do it as your homework problem if you wish to do. And my only motto was to just clear here this concept in the very first lecture or the live session of this reinforcement. So that's what all I have for today's lecture. And you must have also noticed like we have some other questions also, like calculate the maximum bending moment on the beams. That you can do it very easily. Now you have the line load on the beam, and the fourth one is calculate the axial load on the column. That also you can do. You have to only find the support reactions of these beams. The support reactions of these beams would be nothing but the axial force acting on that column. Okay, so that's what all about today's lecture, and I hope. Yes, yes.
Sir, sir, where do you got these derivations? because I was searching for them for a long time on the book, but it was not given.
Yeah,
Which book have you followed?
I have not followed any book. Okay, so even I have learned it from my professors. They have like explained me. Or Shivam, you what you can do? You can just type it on Google. Explanatory form of IS 456 2000. Okay,
Okay, sir.
okay. So you will be get various explanation for these various formulas.
Okay, sir.
Okay,
Thank you,
so
sir, for helping because there are various things that are not given in the book.
yeah, IS code it comes with like ready-made material for you. You can use it directly. You can design your structure directly by using the codal provisions. The codal provisions are designed by years of research and they are kept updated from time to time. Okay, if you want the explanation, you can refer it to the explanatory notes, which you can get it easily online.
Okay, sir. Thank you, sir. Thank you.
Okay, so that's what all about this today's lecture. If you all have any doubt, you can ask me. I'm happy to answer your doubts. Atif is asking anything. Sir, why we are multiplying by unit weight? On which step you are asking? Okay, by unit weight in here for the slab weight you are saying, Atif. Why unit weight? What is unit weight? Unit weight is nothing but the density of concrete. Okay, from
Actually, it is 25. For the
yeah,
plain concrete, it is
yeah.
24.
I understand, Shivam. You can either follow the various dead loads which are given ready-made in IS 875 Part 1. We have all the dead loads for various materials used for construction. But for this problem, it is given like we need to assume 24. This is just a problem. Just don't take it very hard and fast. Okay. So, Atif, what I was saying unit weight of concrete we are taking it as 24. It is basically like a density. So from density we can calculate the mass. Density equal to mass upon volume. But now we are trying to calculate the difference between limit state and working stress method. Yes, recording will be available. The NPTEL team would be sharing it with you. Ajay is asking me what is the difference between the limit state method and working stress method. Okay, so if you like the week 2 content, if you see it, it will be clear for you from that week 2 content. But still, to give you an idea what is working stress method, working stress method, it is basically based upon the stresses, and we calculate it from the maximum forces which is acting on the structure, whereas limit state method we deal from the deflection. From based upon the deflection criteria we are designing the structure in limit state method, and based upon the stress criteria we are designing it in working stress method. Working stress method, it is not very economical. It is underestimating the strength of structure. That is, the structure, even if it can take more load, we are utilizing more material into it and we are making it very uneconomical. Whereas in limit state method we are designing more economical structures by taking into consideration the various serviceability criteria or the deflection criteria. Was I able to answer you? Ajay, was I able to answer you? Okay, fine. Sir, why we are multiplying unit weight to thickness? Okay, I explained you previously also. We are multiplying it unit weight by thickness because we are interested in finding the aerial load. Now this is like volume load. Volume load. Sorry, this is the volume load in meter cube. To eliminate one of the like length from this volume, we are multiplying it by thickness. Why thickness? Because we are interested in finding the aerial load. If you multiply it by this, we will get the aerial load. Aerial load of thickness. 4 into thickness wala. Did you get, Atif, or should I explain it in other way? Atif, did you get me? Yeah, we are multiplying it to convert it into meter square because all of this load they are given for this area 6 into 4 area. So we are eliminating the thickness wala length. How we can eliminate? We can just multiply it by that thickness. Okay, fine. Any other
Sir,
question?
sir, I have a question.
Yes.
Sir, in the book of RCC of by BC Punmia, sir, there the for calculating the trapezoidal load, the formula was WU into LX R upon 2 plus R, where R is equals to Ly by Lx. Sir, it is different from the formula which you have given.
Can you repeat that formula?
W into Lx R upon 2 plus R.
W into Lx R upon 2 plus R. Okay. So that
Actually, it was given in working stress method,
yes, yes.
and it was used in limit state method as well in
Okay.
the book.
Okay, I get you. So, see, basically, we can have different formulas for this load distribution based upon different codal provisions. I can get back to you what is the explanation of that formula in the next lecture if you want me. But for the time being, let the trapezoidal formula be assume this only. If you calculate, let me know what difference in the values you get by using that formula and this formula in the next
Actually,
class.
I had applied on different formulas, just like 4 to 5 kilonewtons value is changing, sir.
Okay, so for this formula, have you used?
Yes, in one of the videos, I was getting something like this formula. In that, from that, I was getting my answer was 15, and the videos and means the YouTube video in which this kind of formula was given, it was 19. So I thought that they are similar, so I used the value of the book itself.
Okay, so what explanation I have for this formula is we are calculating it based upon the maximum bending moment criteria, and the one you are saying 1 plus r, I think that formula is coming from this derivation. If you wish, you can you
Sir,
just
2 plus R.
2 plus r, yeah, can you just try a derivational formula for the case one if you get that formula again?
Sir, what I am not getting what you are trying to say.
I am saying that just derive that formula. Like for the case one, don't take these variables.
Okay.
I have taken these variables now. Just don't take.
The case 1 formula was same, but the case 2 formula for the trapezoidal load, that was different.
Yeah, I got you. I think that is just some different presentation of that formula. I think I will
And
have.
sir, the shear force on the span is just means it is on the safer means it is safe. Being slabs are safe for the shear force, so I thought that not a major difference is there.
Okay, okay. So Shivam, I will have to look at that formula and so because
Also sir, some people are conservative and they are using 0.5 WU into the average of the length of the LX and LY.
yeah,
So
that's what I said. There are different ways in which can you use this. Conservative means if you are getting more value than this, then you can definitely go for it and design. But that would be uneconomical.
yes, sir.
Yeah. So just let me also look at that Punmia formula, and I will also figure out of what you are talking. Okay, Shivam, I will get back you into the next lecture.
Okay, thank you, sir.
Okay.
Sir, you will be there in the next lecture.
Yeah, if you join my session, I will be there here
Uh, Sir, on this day only.
on this day 6 to 7.
Okay, sir. There are different lectures. Means on Saturday there's someone else, and
Yeah, I
on
know, but that depends on you whose lecture you want to attend. It's like that.
okay, okay, sir.
Okay.
Thank you, sir, for this. Sir, I want to ask one more question.
Yes.
It is related to means T beams.
Yes.
Can I ask?
Yes, you can.
Sir, in the T beams there are transverse reinforcement.
Okay.
In the slabs there are top reinforcements. So can the top reinforcement act as the transverse reinforcement in T beams?
Yes, because in during the monolithic construction we do that only.
Okay, sir. Because
Yeah.
in one-way slab, when the span of the T-beam is just parallel to the longer span, then we are not providing with the top reinforcement in the slab. So I was so in that case we have to provide na
Yeah, yeah.
top
I
reinforcement.
know what you are wondering about. But in for your practicing purpose, we are dealing with singly reinforced beams and doubly reinforced beam. But in practical scenarios, we always go for doubly reinforced beam. We have reinforcement both in compression as well as in tension side.
Uh, but they are considered as T-beam na in the design.
Yes, yes. Always there is a T beam because we have a monolithic construction of beam with a slab.
Okay. Okay.
Okay. Okay.
Thank
So
you, sir.
okay. So we have some other questions. What is the difference between a point load and a UDL load? So this is like a very basic question. A UDL load, it is like a uniformly distributed. We never have a UDL. We never have a point load in physically or in a real time scenario. We cannot have a point load. We always have a UDL load. But just for simplification or for building mathematical models, we are converting that UDL load into a point load so that it is easy to do some numerical calculations for the design of our structures. So these are all assumptions we assume. Practically, if you think, I know you are saying it is not possible to have a point load. And the other question we have, sir, can I know the design philosophy of doubly reinforced beam? Difficult to understand AST1 and AST2 and ASC. Okay, so what is the design philosophy? I'm not very sure if the designing of beam has been started into the week 2 content. If you follow up the week 2 content, you would be getting familiar with the various design philosophies. So I would first recommend you to see those lectures very carefully and then come back to me if you have any doubt. Was that clear, Ajay Kumar? Okay, you saw it. So what are you not able to understand? AST1 and AST2. See, basically, AST1, what is it? AST1 is the tensile steel which is embedded inside the beam for taking the tensile forces, whereas AST2 and ASC is the compression force which we have at the top of the beam, and that aerial area of that compression steel at the top of the beam, it is balanced upon by AST2. So we have a see basically see Ajay, just forget everything what I am saying. AST1 is the tensile steel we have at the bottom of the beam, and to balance that AST1 tensile forces, we have the compression of concrete. Okay, now we have AST2 at the bottom. Now to balance this AST2 tensile force, we have ASC steels at the top of the concrete. Do you see how it is working? Tension compression. AST1 is having a compression of concrete. AST2 is having the compression of compression steel ASC. Ajay, you are not getting it. Okay, so to Ajay, what I would suggest you, how if I bring you a more explanatory note in the next lecture explaining you the various aerial steel into the beam? Would that be better for you? Because explaining you like this would be difficult, I think. In the next lecture I will bring some like more notional uh, diagrams of this beam and explain you the different types of reinforcement. That will be more good for you to understand also. Okay, that's fine, Ajay. So I have two works. Firstly, I have to look at that Punmia formula of trapezoidal load, and the other one is I need to have some better explanation for the various reinforcement in doubly reinforced beam. Okay, fine. Anyone else?
Sir, every week, Tuesday, we will have class, sir.
Yes, every week 6 to 7 I will be present here for you to help.
Tuesday, sir, Tuesday.
Yes, Tuesday 6 to 7.
Same, that the Google Meet ID
Same,
can be used,
same,
sir.
same Google Meet ID throughout the
Uh,
semester, throughout the NPTEL course.
Thank you very much, sir. Thank you, sir.
Okay. Any anyone else want to ask something? Today this lecture was just an explanatory or just an design or just an practice problem, you can say. I didn't had any design philosophy today because this was the very first live session. So if there are no questions, I will end this session and we all will meet in the next week with some other good questions, with some other questions which will be clearing more of our concepts in this course. Okay, so thank you. I am ending up this meeting.
Thank you, sir.
Okay.